Welcome and thank you for joining us today for this SPE Tech Talk with Halliburton. I'm your host for this broadcast, Joe Sinnott, coming to you live from Pittsburgh, Pennsylvania. And I'm excited to dive with you into cement. In particular, Portland cement, which accounts for approximately 99% of the mass of the slurry design and the majority of the carbon footprint associated with well cementing, due to the CO2 that is released during the manufacturing process. So, for oil and gas companies aiming for a lower carbon future, it is beneficial to have dependable zonal isolation barriers with reduced cement content. We're joined today by Halliburton to discuss how their reduced Portland systems can provide enhanced barrier performance and help operators lower carbon emission baselines. And although we'll be talking about isolation and barriers over the next 30 minutes, we want to remind you, the audience, that there are no barriers isolating you from our expert here on SPE Tech Talk. In fact, all you have to do is use that comment box to help drive this live show forward. So please take advantage of that comment box by asking your questions about today's topic, and our expert will get to as many of them as possible later on in the show. You can also use that comment box to let us know where in the world you're watching from and to answer today's audience poll question, which is a carbon footprint reduction important to your organization? A, very important and you'd like to learn more. B, somewhat important but not ready to implement new technologies. Or C, not on our radar. Let us know your answers in the comment section, and we'll take a look at the results later in the show with our guest. And speaking of our guest, let's go ahead and introduce Brittany Clark, who is joining us today from Houston, Texas. Brittany is Global Product Champion with Halliburton and currently focuses on supporting cement chemistry and applied science projects. She has over 13 years of experience with Halliburton cementing and has had a range of roles, including field engineering, technical sales, and area technical advisor. She has authored and co-authored 4 technical papers on topics in casing pressure. Brittany holds a degree in petroleum engineering from the University of Texas. Well, hello, Brittany, and welcome to SPE Tech Talk.
Hi, thanks for having me. Excited to be here.
All right. Well, we are excited to have you, Brittany. And if you would, could you kick us off with an overview about cementing and how cementing in particular contributes to CO2 emissions and, of course, why Halliburton decided to go and develop a portfolio to address reducing Portland cement in your systems?
Yeah, absolutely. I think it's important to understand why we're focusing on reducing Portland content when we're talking about reducing CO2 emissions from cementing operations. So if you look at on a broad scale, cement manufacturing globally accounts for about 8% of total worldwide CO2 emissions. Now that's all cement manufacturing, so that includes construction cement as well. Oil-filled cement-specific manufacturing is only a small percentage of that, less than 3%. But when you look at the cementing operations, everything from start to finish, what goes into putting a cement job in the ground and what contributes to that total CO2 emissions, when you're looking from lab testing, all the activities in the bulk plant, loading cement, transferring that cement, the personnel, the blends from our site to the job site, everything that happens on job site, mixing, pumping, cement. When you look at everything beginning to end, the materials that are pumped down hole are the largest contributor to CO2 emissions. And by far, the major contributor is that Portland cement. So when we look at how can we move the needle the most in reducing cement's impact to the overall emissions, reducing Portland is how we can really move that needle. So in addition to reducing the Portland systems that we're going to talk about today, I also want to highlight that Halliburton also has non-Portland cement systems as well. And each non-Portland system fits a different scenario and challenge depending on what the customer is trying to achieve and what you need out of that barrier. But I want to point out that non-Portland doesn't specifically mean lower CO2 emissions. When you look at non-Portland systems, they require a different type of chemistry And those materials that make up that system can be heavily mined and manufactured and actually have higher emissions on those materials as well. So what's nice about our reduced Portland system portfolio is we primarily focus on local byproducts with some minor, some manufactured and mined products, really focusing on a full sustainable solution.
Got it. So based on what you just described, there's a pretty big carrot out there in terms of wanting to reduce the carbon footprint. But can you shed some light on how Halliburton went about that? What was the approach that you took to, again, see this opportunity and come up with some reduced Portland systems to address that carrot, if you will?
Yeah, absolutely. So it's really been an evolution that started with our Neosem system. So if you're familiar with Halliburton cementing, you've probably heard of Neosem system. We commercialized it about 6 years ago, and it really was 10 years ago where we started really the R&D behind it. And what's different is we've looked at tailoring and engineering these designs specifically. So taking a look at the individual components that make up the blend, looking at their chemistry and their physical properties. So we're truly engineering these designs based on the materials. And so Neosem was really the foundation and the stepping stone that's got us to where we are today with our reduced Portland portfolio that we're going to talk about. So from there, we've really just continued to evolve that engineering and tailoring. We've begun to leverage our immense database of lab testing along with that physicochemical understanding. And then from there, we're able to identify materials that are going to bring the most value to our systems to reduce that Portland content. It's important that we're not just reducing Portland and replacing it with water. We are selecting high performance supplementary cementitious materials to replace that Portland content. So we're creating a better engineered system.
Got it. So I guess building upon that a little bit, Brittany, you're building the system. You've talked about some of the benefits. So what other benefits, right? I mean, what other carrots are out there when it comes to this?
Yeah, absolutely. So by taking more of an engineered approach to how we're designing these systems and looking at the individual materials that we're using to reduce the Portland, we're easily able to achieve a wide range of benefits from the slurry. So when we're talking about just performance, not only are we able to tailor these blends to better and more effectively and efficiently achieve good slurry properties, meaning thickening time, fluid loss, stability, but more importantly, when you're thinking of the long term of having a dependable barrier, the way we engineer these systems also helps with those set cement properties. So focusing on building better compressive strength from lower density solutions. And we really focused on the toughness or ductility of these systems. So looking at the compressive strength over the Young's modulus to get an estimate of, again, how ductile these systems are, how well they're going to hold up for the life of the well, for the operations that cement sheath is going to need to withstand for the life of the well. Another property that we've seen very impressive improvement is actually the permeability of the system. So looking at the permeability of the set cement sheath, the tighter the permeability, the better that system is going to be at being resistant to corrosive fluids and gases and any fluid influx. So we've seen improvement in slurry properties, set properties, including ductility and permeability. The other thing that's really beneficial about this approach is that we're not focused or sourced on one specific material or manufacturer or vendor. It's not like we've got one certain material that makes this system that we've got to ship globally. This engineered approach is very flexible in that it is focused on each geographical region or area. What materials do you have in your area? And with this engineered approach, we're better able to identify materials, sustainable, supplementary cementitious materials that we're replacing the Portland with in each geography, that we may not have previously used or had in our portfolio before. So finding these additional materials really gives us flexibility too from a supply chain standpoint. In no matter where we are in the world, we can go out and find materials to help engineer these reduced Portland systems.
Great. Well, building off of that, Brittany, you talk about getting materials from all over the world. I know we have an audience that's tuning in from all over the world. So I want to encourage that audience again to use that comment box to share your feedback about this, your comments, your skepticism about some of the things that Brittany may have said, and of course your questions. And we'll get to as many of those comments and questions later on in the show as possible. And again, to reiterate what we said at the opening, the beauty of these live tech talks is that there is no barrier between you, the audience, and our technical experts. So ask away, get your questions answered here, and take full advantage of everything that SPE is bringing to you today. That being said, Brittany, I have plenty of my own questions to keep asking. And of course, to this point, you've shared why this all matters. You've shared some of the benefits. You've shared how Halliburton's gotten to this point, of course. So can you boil that down into some of the successes that you've seen, right? I mean, what successes have you experienced using everything that you've just described for us in the opening of this show so far?
Yeah, I want to get to the successes, but I feel like it's need to kind of outline the portfolio of the systems that we're talking about here. So I've talked very, like you said, macro of how we do it, but what are these systems that I keep talking about, our reduced Portland portfolio? And I've got a visual that we can pull up here. Yeah, so this is kind of the breakdown of what I've been talking about, our expanded reduced Portland portfolio system. So I mentioned NeoSim. Again, NeoSim is inherently reduced Portland. That was really our jumping point, our first step into engineered reduced Portland designs, focusing on low density, high performance reduced Portland systems. But when we rolled out NeoSim, the primary objective was not necessarily Portland reduction. So we've really had a wide range of Portland reduction on the NeoSim system, depending what basin or customer we're running it for. But on average, it's about a 40% reduction in Portland. So because of that variance, we kind of wanted to set a standard for a more sustainable, lower Portland NeoSim, and that's our NeoSim E+ system. So to qualify as that system, it has to follow, again, that same methodology and engineering that we've used from NeoSim, and taking that one step further and focusing on that reduced Portland. It has to have less than 50% by mass Portland of the entire blend. And that is our NeoSim E+ system. And then from there, again, taking that one step further, pushing that Portland reduction, is our EnviroSim system. Again, EnviroSim follows the same engineering and methodology, and it has a max Portland content of 30% of mass Portland of the blend. So a 70% reduction when you're comparing it to a 100% Portland blend. So significant Portland savings, and therefore reduction in CO2 of those systems.
Wow, that's great. Well, thank you for expanding the depth of everything Halliburton has done, right? This, as you've made clear, this isn't just some one-stop shop here. You're navigating the materials that you have around the world, and clearly you have a lot of different avenues to do that. So appreciate you sharing the differences. And so again, I'll come back to the question that I asked earlier then, with all of this portfolio and all of the different options and your ability to adapt to, different scenarios around the world, what are you seeing? What are some of the successes that are resulting from everything you've just described, Brittany?
Yeah, absolutely. So let's start by talking about EnviroSim. So again, that's EnviroSim has less than 30% by mass Portland. And we focused our initial rollout of EnviroSim in the basin, being the largest shale basin and one of the most active, is one of the areas where we could do the most, again, move the needle the most from just how much consumption of Portland there is. So we looked at the production designs that we were running in the Portland today, in the Permian today, and we designed an EnviroSim system for the densities that we're currently running, the objectives that the design needs to meet in the Permian Basin, and the objectives and expectations of the clients to essentially have an EnviroSim portfolio of several different densities for production slurries. To date, we've run over 120 Envirosym jobs in the Permian Basin. That's over 70,000 barrels. So a significant amount of Envirosym, and we're still looking to not only grow that in the Permian Basin, but other assets and locations globally. The other success I want to highlight is around where we've utilized Neosym E+. I think this is really exciting because it's offshore. Historically, it has been challenging to run different types of blends, including Neosym, in offshore locations because of the versatility that you need of a blend for it to be operationally efficient offshore. So when we were focusing on designing the Neosym E+ blend, specifically for the North Sea and offshore, we had a few objectives that we're really trying to meet. One, reduce that Portland content with sustainable materials that are efficient and operationally achievable. And then making sure that the logistics of these materials and that it was going to be a very versatile system that we can use in multiple scenarios on that rig, not just a blend that can be used for one job, one time. So that's exactly what we did, is we designed a versatile blend that can be used across a wide range of jobs by focusing on reducing Portland content and minimizing any addition of weight on cement time while keeping that performance. So I've got another visual for that one to kind of look at a breakdown of the versatility. All right, so again, like I said, it's a very versatile system. So this one blend that we can take out to the rig, we have a range of densities that we can pump and tailor this design to, depending on the job application. This specific blend that we've been using can be tailored from a 13.35 pound per gallon up to a 14.6 and still have a stable design with controllable fluid loss and thickening time. So we're able to tailor this blend offshore using the liquid chemicals that we already have on location. And often, because we have a more efficient designed blend, we may even need less addition of chemicals than we typically would for a system. So we're able to achieve all these objectives across, again, a wide range of temperatures and densities. And so all while, again, meeting the strict requirements of North Sea export cement design. To date, we have run the system in the North Sea on over 30 jobs. And I think more impressively is we've used the same blend to pump a wide variety of jobs. We've pumped foam surface casing jobs with this base blend, surface casing jobs, surface plugs, P&As, production casings, production liners, all using the same base blend and just tailoring it with our liquid additives on location. So that aspect has been really exciting, being able to see where we can take these reduced Portland systems offshore, which has kind of been challenging in the past.
Great. Well, thank you for sharing that. Again, thank you for sharing your excitement, I think, about where things are headed, right? Which I guess begs the question, Brittany, you know, given your, 13 years of experience all in the cementing world, everything you just laid out now in terms of the innovation and the change and adapting to all of the requests from clients, can you peek into your crystal ball and project what's next? What's on the horizon here? What are you betting on the future of cement to be?
Yeah, so I mean, our first step here is taking our portfolio and our engineered approach and expanding it globally. Like I kind of mentioned in the beginning, I think that's what is so great about this reduced Portland blend portfolio is that it can truly be tailored to what location you're at globally, what local materials that you have. So from here, we're really just trying to expand usage. The end goal would be to have these systems available in any location globally across a wide range of applications. We really want this system to really take over the majority of designs that we pump to, again, build towards a more sustainable cementing operation. These aren't just niche designs that can only be used in one application or one area. This system could truly be really leveraged across the globe. And then from there, we will continue to evolve these systems to, again, further push that reduction of Portland in our limit as we identify new supplementary cementitious materials that are recycled byproducts, again, further reducing those emissions and creating a more sustainable blend.
Great. All right. Well, thank you, Brittany, again for setting the stage here and explaining sort of the past, present, and future of cement, which I think is a good time to revisit the poll question that we asked earlier. So it's one thing to talk about what's out there, but the question is, what's motivating our audience and the companies that they work for? So at the beginning of this episode, we asked, is a carbon footprint reduction important to your organization? And, A, very important, B, somewhat important, C, not on our radar yet. The majority of people so far have said that, yeah, it is important. They are interested in things. So I guess my question for you is, what's your take? What are you seeing? What is the consensus from companies that are out there? How important is the CO2 reduction, carrot, if you will, the impetus for all this? What are you seeing from companies out there, Brittany? And are you surprised by the results so far of the poll question?
Yeah, that's in line with what we've seen and not surprising. And we've really seen that interest continue to grow. And, that's why you see that first real implementation of the Neosym E+ in the North Sea, because that part of the world and that geography, they are very conscientious on proactively reducing their carbon footprint and their emissions. I think we're continuing to see the interest grow in other areas globally. And a lot of it always comes down to the cost of the systems as well, which again, I think is another great thing of these systems is they can be very economical solutions to still reducing the emissions of the blends with these sustainable solutions.
Great. All right. Well, again, audience out there, you hear we're talking about you now. We're talking about you and what you think and what you want. So now is a good time to chime in with your questions, comments, corrections, if you will, before we have to wrap up this show. But for now, we do have time for plenty of questions, Brittany. So I guess my follow-up one, sticking with sort of what's on the mind of your customers and operators out there, when you have clients that are asking for non-Portland systems, what is it that they're asking for when they want to go down that path?
Yeah, so it's a kind of an important question to ask, and it could really go down a lot of rabbit holes with that question, but I'll try and keep it high level. So non-Portland, a lot of the drivers today are typically from a specific application. You need a barrier that is non-Portland, that is going to be sustainable for carbon capture and storage wells, or something that is going to be utilized for a specific application. I'll just say with all of these different asks when it comes to non-Portland or CCUS or reduced Portland, it's really important for the operators to know and understand when you come to us as your cement provider of what expectations you have of that barrier, what challenges that barrier is going to see for the life of the well, and how long that barrier needs to hold up and to what capacity.
Got it. So assuming you're able to convey that, the all-important question of what their goal is, what do you think about adoption in the future? What's your again, prediction, if you will, in terms of the adoption of everything we're talking about moving forward?
Yeah, I think it's going to continue to grow. Again, when we're looking at the reduced Portland system, so let's take, for example, the Neosym. So again, we rolled out Neosym about 6 years ago. North America land has a very broad range of SCMs that we can utilize that are high quality performance to replace Portland. So if you look at the Permian Basin today, I would say over 65% of every slurry we pump in the Permian Basin is already a reduced Portland system. Again, they're either Neosym or we've transitioned them over to Neosym E+ or EnviroSym. So I think as we continue to design these systems globally and identify sustainable materials from sustainable sources, then it'll continue to grow that way, and we'll start to see that same effect of where each location, the majority of their designs are moving towards reduced Portland systems.
Got it. Okay, well, thank you for that. Coming back to our audience, maybe a question inspired by one of our audience questions here, and that would be about compressive strength. So when we're talking about these different systems, can you talk about sort of how the compressive strengths compare among different systems?
Yeah, absolutely. So that's a good question that, and I'll kind of back it up to NeoSim as well. So when we first transitioned to NeoSim, many operators were still running 100% Portland, 16 pound per gallon, 16.4 pound per gallon blends that would achieve 3,000 plus often final compressive strength. When you swap to a lower density, but still high performing design, you may have a lower final compressive strength, but that's not necessarily a bad thing. And it's important to focus on how ductile the system is. So just because the final compressive strength is not 4,000 PSI, it's still more than adequate to what we're pumping today and what we need on the completion side for isolation. What's important is that the Young's modulus is also improving, so we're having a more ductile system. So these systems that have a lower compressive strength may actually be better in the long term from a ductility standpoint than a higher compressive strength, more brittle design. So that's one aspect of it. Again, there can be limitations as well as far as how quickly compressive strength builds. I think it's another initiative that we've worked and engineered around a lot to ensure that we're getting fast compressive strength development from these low density systems so that operators are able to be operationally efficient as well.
Got it. Okay. Well, I guess at least one other question for me then, whether it's on the technical side, whether it's on the operational side, whether it's on the, whether you're motivated by carbon footprint reduction or not, what kind of skepticism, what kind of naysayers are you finding out there? Because again, I know our audience, they might be a little bashful today, but again, sometimes we're skeptical of some of these things and whether they're going to work, whether they're going to be repeatable. So, as we kind of close in on the 30-minute mark, Brittany, what would you say to some of the skeptics? And is there a typical skeptic out there that may not be all in on everything you just described for us throughout this episode so far?
Yeah, I'm going to answer that in two parts if I can remember it. So the first side of that is you kind of got the same, going back to what I was with the final compressive strength being lower. And when I say lower, I'm still talking 1,500 to 2,500 PSI final compressive strength. We first rolled out the NeoSim reduced Portland blends. That was a big concern for operators because it's reduced Portland and has lower compressive strength. Is this going to affect our completions and our production of these wells? So from that point, there was really a large scale field trial that operators were doing, comparing the not only performance of isolation, looking at any changes to annular pressure, but also from how their completions were being executed and the production of those wells to make sure there was no negative effects going from this higher density 16.4 to these reduced Portland engineered systems. And what we saw was there was no negative effects, if anything, more positive. So with that, we were kind of leveraging that on these new systems, as well as from all of the lab testing we've done, looking at the improvements of the NeoSim that we've been running and has already been kind of validated from a bond log and production standpoint with improved ductility, improved permeability, improved design. As we move forward and design more of these systems, we are further fine-tuning how we're engineering and tailoring these designs to make them more efficient and higher performing.
Great. Well, thank you for that, Brittany. Thank you to everyone who's asked a question so far today. We might not be able to get to all of the questions, of course, but continue asking your questions. Again, on the recording here, keep throwing them in there. We'll get answers to them. But for now, Brittany, as we wrap up here, any final words, anything else that you want our audience to know about these cement systems and everything you've described for us today?
No, I just say, I think if you're an operator interested, reach out to your local Halliburton rep. And if we do not already have designs available in your geography or basin, we can work to design them as well.
Okay, great. All right. Well, as the clock ticks down, one more lightning round question, okay? Because John Knowles on Energy Stream, he just asked, in terms of an HSE standpoint, does the NeoSim solution contain respirable crystalline silica? Any final answer here from this lightning round question as we head to
So
the
that's
finish line?
actually a really great question, and one of the benefits of these systems. As many of you know, when you typically use crystalline silica at 35% by the weight of the cement. So as we reduce the Portland out of these systems, not only do we need less crystalline silica, but a lot of the SCMs or supplemental cementitious materials that we're adding in there can kind of replace that need for crystalline silica without that additional HSE exposure. So great question, and definitely a good HSE benefit as well.
All right. Well, next time we talk, Brittany, we can build on not just the environmental, but look at this. We segued into the safety side of things as well. That's fantastic. All right. So with that being said, Brittany, thank you so much again for your time, for your answers, for the thorough history and some peek into the future on the world of cement, and appreciate you for all of the insights that you shared on reduced Portland high performance systems. You alluded earlier on, way people can get in touch. What is the best way for people to get in touch again, if they have additional questions for you or for Halliburton about everything we described today?
Yeah, you can always reach out through LinkedIn, and we do have material and data sheets available on our external Halliburton website as well. So you can search for any of those systems or reach out to your local Halliburton rep, and they will get you in contact with the right people.
All right. Well, audience, you heard Brittany's invitation. I implore you to take advantage of it. But with that, again, I thank you, the audience, for tuning in and for participating today. I thank you again, Brittany. And of course, I thank Halliburton for helping to make this episode possible today. If you'd like to watch a replay of this episode, you can do so over on the SPE Energy stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
In a rapidly evolving energy industry, you need to stay ahead of the curve with relevant content available when and where it's convenient for you. You need the upgraded SPE Energy Stream, the global platform for high-quality content with the energy industry. Fuel your energy career with Energy Stream's sleek new look and easy access to top-quality technical solutions, insights and innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event highlights, this exciting, easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders. Then save the videos that interest you and watch them at your convenience. Be at the forefront of energy knowledge and explore the newly updated SPE Energy Stream now.